Dear students, welcome to my video, Chapter 15 Probability, Part 1. What is meant by probability or possibility? In everyday life, we come across statements such as, "It will probably rain today." "I doubt that he will pass the test." "Most probably, Kavita will stand first in the annual examination." "Chances are high that the prices of diesel will go up." "There is a 50-50 chance of India winning a toss in today's match." These all statements are very familiar in your day-to-day life. Then you can observe that some words. What are the words? Probably, doubt, most probably, chances, etc. It is used in the statements above involve an element of uncertainty. For example, in the first one, probably rain will mean it may rain or may not rain today. We are predicting rain today based on our past experience when it rained under similar condition. That means sometimes it happens or sometimes it does not happen. That means we cannot predict the correct answer before these all experiment. See, these five are an experiment. We can take an experiment. Before that experiment, whenever we cannot say the correct answer. So, probability is defined as the numerical method of measuring uncertainty involved in a situation. That means we have to measure the uncertainty by using numbers. And also, it is widely used in the study of mathematics, statistics, gambling, physical science, biological science, weather forecasting, finance, etc. to draw some conclusions. Okay, tossing of a coin and throwing of a die. It is the some examples of uncertainty. You can see that before a cricket match starts, captains of two teams go out to toss a coin to decide which team will bat first. So, what are the possible cases? Uh, Only two result. One is head or another one is tail. But before the tossing of a coin, we cannot predict the correct result. Can you control the result of the toss? No, that is not possible. So that type of experiment is known as random experiment. Similarly, throwing a die, it is also an example of random experiment because we cannot predict the answer before this experiment. So an experiment in which we know all the results but cannot predict them is called a random experiment. So what is mean by outcomes? The possible results of an experiment are called the outcomes. For example, tossing of a coin. What are the outcomes? Only two. What are they? Head and tail. The next one is trial. Trial means a single performance or single action of a random experiment is known as a trial. For example, tossing of a coin. I tossed a coin 100 times. So each toss of a coin is called a trial. Then sample space. The set consisting of all possible outcomes of a random experiment is known as sample space. Example, throwing a die. So we know 1, 2, 3, 4, 5 and 6 are the 6 members in is a set. So that set is called sample space of a die. Then event, a subset of the sample space of a random experiment, is called an event. Simply, we can say event is a collection of some outcomes. So, for example, throwing a die and getting a even number. What are the even number in a die? 2, 4, 6. So 2, comma 4, comma 6 is an event. Then we can find the probability by using formula, that means experimental or empirical probability. So here let n be the total number of trials and m be the favorable event. The empirical probability P of E of an event E happening is given by P of E is equal to number of trials favorable to an event divided by total number of trials, that's equal to M by N. Also, the probability of any certain event is every time 1. The probability of an impossible event is every time 0. And we can say any probability in between 0 and 1. That means sometimes you will get answer is 0 or 1 or in between 0 and 1. Every time the result 0, 1 or in between 0 and 1. Now let us consider some examples. Question number 1. A coin is tossed 1000 times with the following frequencies: head 455, tail 445. Compute the probability for each event. Question is given that coin is tossed 1000 times. So here we have two events. The first one is event of getting a head and getting a tail. So we can take one is calculator E, the second one is calculator F. Then the number of times E happens, that is number of times a head comes up, is 455. That means the event E means head and the event F means tail. So what is the formula? Number of trials in which the event happened divided by the total number of trials. That is the probability of E. Simply we can write the probability of E is equal to number of heads divided by total number of trials. That is P of E is equal to number of heads is equal to 455 divided by total number of trials is equal to 1000. So the answer is 0.455. Similarly, the probability of the event of getting a tile, how to write? Number of tiles divided by total number of tiles. That is equal to P of F is equal to 545 divided by 1000. That is equal to 0.545. Then you understand one more fact. Add the total probability, that is P of E and P of F. Add these two events or two probability, you will get 1. That is P of E plus P of F is equal to 0.455 plus 0.545, that's equal to 1. Total probability is equal to every time 1. The next question, two coins are tossed simultaneously 500 times and we get two heads 105 times, one head 275 times and no head 120 times. Find the probability of occurrence of each of these events. Question is given that there is a two coin and it is tossed at the same time. So what are the outcomes? We know 2h, 2t, that is 2 head, 2 tail, one head and one tail, or one tail and one head. Here we have three cases. One is two heads, that is how many times? 105 times. One head comes up. So what? How many? 275 times. And no head, that is 120 times. So we can take the events of getting two head is calculator E1 and one head calculator E2 and no head calculator E3. Therefore, the probability of even means two head. How many times? The 105 divided by total trials 500. So 105 divided by 500 is equal to 0.21. Similarly, P of E2 is equal to 275 divided by 500. That's equal to 0.55. Then probability of E3 means no head. That is how many times? 120 divided by total trial 500. That's equal to 0.24. And also you add these all answers, that is all probabilities, you will get answer is 1. Then next question, a die is thrown 1000 times with the frequencies for the outcomes 1 comma 2 comma 3 comma 4 5 and 6 as given in the following table. Find the probability of getting each outcome. So here the outcomes 1, number of frequency is equal to 179, 2 150, 3 157, 4 149, 5 175 and 6 190. So we have to take E1, E2, E3, E4, E5 and E6 are the 6 events. Here P of E1 can be written as frequency of 1 divided by total number of times the die is thrown. That's equal to 179 divided by 1000. That's equal to 0.179. Then probability of E2 can be written as 150 divided by 1000. That's equal to 0.15. Similarly, you will get P of E3 is equal to 0.157, P of E4 is equal to 0.149, P of E5 is equal to 0.175 and P of E6 is equal to 0.19, and also you will get total probability is equal to 1. The next question, the record of a weather station shows that out of the past 250 consecutive days, its weather forecast were correct 175 times. Sub-question A, what is the probability that on a given day it was correct? And sub-question B, what is the probability that it was not correct on a given day? So what are the given measurements? Here we have 250 consecutive days and taken some weather reports, and 175 times it is correct, and balance it is not correct. So we need to find the probability of in each case. So we can take the first probability is the event is correct one and the second event is not correct. Okay. Therefore we can write P of the forecast was correct on a given day is equal to number of days when the forecast was correct all divided by total number of days for which the record is available. That's equal to 175 days is correct and divided by total number trial 250, that's equal to 0.7. Then sub question B, then here probability of the forecast was not correct on a given day is equal to, here we know the correct is 175. You subtract this number from 250, you will get 75. So 75 divided by 250, that's equal to 0.3. And also you will get total probability is equal to 1. The next question, the percentage of marks obtained by a student in the monthly unit test are given below. Based on this data, find the probability that the student gets more than 70% marks in a unit test. Given that 5 unit test and its marks, and we have to take total number of unit tests is equal to 5 and number of unit tests in which the student obtained more than 70% marks is equal to how many tests is the here 1 2 3, so 3 times, so 3 in a unit test got more than 70%. So probability of scoring more than 70% marks is equal to 3 by 5 is equal to 0.6. Then next question, 50 seeds were selected at random from each of 5 bags of seeds and were kept under standardized conditions favorable to germination. After 20 days, the number of seeds which had germinated in each collection were counted and recorded as follows. So what is the probability of germination of subquestion A, more than 40 seeds in a bag, then 2, 49 seeds in a bag, and 3, more than 35 seeds in a bag. Then how many bags are there? 5. And number of seeds germinated is also given. And we have to take the first one is event 1. Okay. That is, the first event is germination of more than 40 seeds in a bag. So how many bag is the 3? More than 40 here, 3. So 3 by 5 is equal to 0.6. Then the second one, number of bags in which 49 seeds germinated. Here there is no 49 seeds, so the answer is 0. So probability of germination of 49 seeds in a bag is equal to 0 by 5, that's equal to answer is 0. Then third one, number of bags in which more than 35 seeds germinated. How many times, how many bag is the 5? So the required probability is equal to 5 by 5 is equal to 1. Thanks for watching my video. Please wait for next video. Thank you.